For the second do know in week 6, it talks about research summary, and you're looking at a map of an experiment that was done here and trying to find out the answers. So the first question says, which conclusion is best supported by the results of experiment 1 alone? Silver ions are present only in solution 3, no ions are present in solution 4, lead ions are present in solution 1, 2, and 3, no positive ions of silver, mercury, or lead are present in solution 4. So, if you go back to the experiment map here, you can read where these precipitated out and where you have ions. So the answer to number 1 is actually D. No positive ions of silver, mercury, or lead are present in solution 4. So you have to go through and read through. So when they added HCl, these precipitated out for solutions 1, 2, and 3. So that would be the ions precipitated out in powder, but nothing happened here. So we don't have any ions that left solution 4 on the step 1. Then they put them out. So precipitate in solution 1 redissolved completely, which means the ion is back in solution 1, and it's still out in 2 and 3. And then solution 4 was unchanged, which means we still have not seen a new precipitate come out, which means we still don't have ions here. Then solutions 2 and 3 were centrifuged to remove the precipitates, which were retained for further testing. Potassium chromate was added to each sample. Bright yellow precipitate formed in solution 1 and 2, so that means there are ions there. None formed in solutions 3 or 4. The white powder centrifuge in experiment 2 was treated with aqueous ammonia, and then the precipitate in solution 2 returned, which means we have ions in 2, while that from solution 3 produced a gray powder. That means we have ions in 3. So the answer here is actually D, because nothing ever precipitated out based on that map. So that means we can't actually identify any ions being there. Number 2, based on experimental results, which ions did solution 2 contain? So the answer to number 2 is actually G, lead and silver ions only. So if you read through here, you have to walk through the flow chart. So we know that heating it caused PbCl2 to dissolve, and then it has something other than lead in it because it still makes a precipitate. So we know that there's lead because it does a precipitate in this step when the yellow powder forms. But because PbCl2 comes out and then dissolves back in, Pb is equal to lead, so we know that that's in there. And then if you follow all the way through the pathway to the bottom, you have AgCl dissolves in solution 2. So this precipitate, AgCl, redissolves, so that's solution 2. And Ag, as you know from all of our Canvas documents, is silver. So if you follow the flow chart down, you're going to get lead and silver ions only. It might be tempting to go to the bottom of the flow chart and pick J, silver ions only, but we know at this point that PbCl2 is dissolved into solution 2 and that lead doesn't come back out, which means that solution 2 at the end of it still contains lead and silver because both of these things redissolve in solution. Number 3. The yellow precipitate that formed in experiment 2 was most likely. So if we go through here, experiment 2, we had, these are our precipitates, then we had them in a water bath. Solutions 2 and 3 still contained a white powder. Solution 4 was unchanged. Solutions 2 and 3 were centrifuged to remove the precipitates and retained for further testing. Then you add potassium chromate and a bright yellow precipitate. So we know that we took all of these precipitates out and then retained them for further testing. So the answer for number 3 is C because chromate is the only thing that we added. So if you go to this step, PbCl2 is dissolved, and then you add CrO4 and you get a yellow powder. Lead is dissolved in the solution. It's going to bind in a double replacement reaction so that it's KCl and then PbCrO4. All of these are things that they actually say are retained for further testing, and we have no evidence that there's silver in the solution yet. The experimental results suggest that if lead chloride were treated with aqueous ammonia, the results would be. So The answer to number 4 is actually J. So the passage doesn't provide any evidence because we have PbCl2 dissolved, and you attack it with potassium chromate, which is here, but it doesn't say anything with PbCl2 and aqueous ammonia. So these are two separate branches of the flowchart. There's no connection to right here, which means it's actually impossible to determine. This is a very, very rare answer to have on the ACT. You will almost never have it, but if in this case the two data representations aren't connected at all. And then number 5, a student proposed that the analysis could be carried out more efficiently by heating the samples to 100 degrees Celsius before adding the 6 molar HCl. So this asks you to evaluate their procedure. A bad idea, a bad idea, a good idea, and a good idea. If they give you 3 of one option and 1 different, so if this was 3 bad ideas and 1 good idea, immediately cross off the good idea, because they're not going to give you 1 yes and 3 no's. They'll give you 3 maybes and 1 no. But here we have it split into 2. So heating all of the samples first is going to change the results. If you look at here, so we know that when we heat this to 100 degrees Celsius, this dissolves back in. So if we wanted to heat this first and then add 6 molar, then we wouldn't be getting the precipitates because the reaction is too hot. So it's like a catalyst. So if we dissolved this back into the solution, we would never see PbCl2 in the first place, which means that we would not get the right precipitates to form, and we wouldn't be able to figure this out. So it's going to be a bad idea because then we could not detect the lead ions.